Welcome back to season 3 of Navigating Nano podcast at the Joint School of Nanoscience and Nanoengineering. And this is our first episode of season 3, and we are here with Dr. Behnam, and he's going to teach us how to pronounce his second name because I cannot pronounce it. And I'll be your host, Faith Zablon, and give a shout out to our editor, Gerald Badu. So we are honored today to have a sit down with distinguished Professor Dr. Behnam. Could you please teach us how to pronounce your second name because I don't want to make an error.
The second name is Pourdeyhimi.
Pourdeyhimi.
Mm-hmm.
Okay. Welcome. And he is a professor from NC State in Nonwovens Institute of Wilson College of Textiles. I got it right. Yes. So Dr. Behnam, could you please talk to us a little bit about who you are? We already know who you are, but there's that simplified way of telling a normal audience who you are and what you do. Yes.
Well, I'm a professor at NC State, and I direct the Nonwovens Institute. And my research deals with fibers, polymers, and nonwoven structures. Mm-hmm. And I've been doing this for a long time.
Oh, a long time is how long?
Too long.
Okay. Okay, that's good. And what else? Where are you from? Your background?
I grew up in the UK, and I finished my undergraduate and postgraduate and received my PhD, and then came to NC State, didn't stay very long, went to Cornell, then University of Maryland in College Park, and bypassed NC State, went to Georgia Tech for a few years, and came back to NC State in 1999.
What drew you back? Those are like 3 times you came back to NC State? Mm-hmm. Why?
Well, I think the attraction to NC State and coming back was really the nonwovens activities that had grown. Mm-hmm. I had a colleague who had started the program, and we were collaborating on nonwovens, and so that was really the attraction.
Okay. Yeah, I've heard it has the best textile institute, mm-hmm. probably in North America. I think that's what I hear. Yeah. Okay, that's wonderful. So we'll dive in and just get to talk to you a little bit more on various topics, non-conventional, where you come from, your culture, and how we can be able to relate to it. So my first question will be what spiked you into the interest of nanowoven and textile? And when did you get the interest to get into it?
Well, I actually learned about nonwovens when I was an undergraduate student, mm-hmm. and what really interested me was that there was no specific nonwoven, that you really had to create nonwovens to solve problems, and if you look at the applications, it goes far beyond your typical fiber and polymer applications.
Okay.
And it can touch a lot of different markets, many segments. Mm-hmm. And very few people knew about nonwovens, and so I decided that when I came to the U.S., I actually went to a nonwoven show in Baltimore, Maryland, and I was fascinated because I'd never seen such a thriving industry.
Okay.
Diversity, mm-hmm. big companies, and thriving, and then the academia really not engaged in nonwovens at all. It was a little bit too interdisciplinary at the time, mm-hmm. and so that's how it started.
Okay, and then the passion. So you got to finish your undergrad, then you joined a PI who was working with textiles, mm-hmm. and mm-hmm. how come you came to the United States from the UK?
Well, it's really a very simple story. So there was a English professor that worked at NC State. Mm-hmm. And so I knew him. We had discussed various things with him, and he actually said, "Well, when you finish your PhD, let me know. You should come to NC State."
Okay.
And so he essentially recruited me, and I came, and that's how it happened.
Interesting. So how was that transition? As you can see at the Joint School, a diverse group of students from all over the world, and you came from the UK. How was that transition for you? So I know it's a long time, but can you remember a little bit how you transitioned?
I do. I guess at the time I had a sort of a North British accent, a Yorkshire accent, and so.
And you lost it.
I can put it back on.
Okay.
And so my people that I interacted with were really fascinated. The accent was different, and then the students used to complain because I would misspell things like fiber and center, and because the E and the R go the other way, but it was really not a difficult task to really adjust.
I can imagine, in Britain, the roads, I come from Kenya, it's a British colony. So I understand the English, but even the structure it just say, for example, the roads. In the United States, they drive on the right and we drive on the left.
Yeah, they drive on the wrong side of the road.
They drive on the wrong side. They say we drive on the wrong side of the road. But yeah, so I can only imagine. Did you ever go back after you came here?
So I still have some really good friends. And I was there actually in 2018 for the World Textile Congress. And I was at Leeds, and I visited my former PhD advisors, and yeah.
Okay, so have you established collaborations in the UK? Now that you came from there?
We do have collaborations with the University of Loughborough in the UK. And so they're actually part of our community, and some of our former students who worked on nonwovens are now professors at Loughborough, and they will continue the tradition of collaborating.
Wonderful. Yeah, okay. Yeah. So you talked about I liked the presentation that you gave us today. We are in an era of the pandemics. We had the COVID pandemic, and the role of nonwovens obviously shone so highly during the COVID pandemic. Could you share a little bit on what is the critical need when it comes to medical applications of the nonwovens?
Yeah, so I think the shortage that we had really fell into two major categories. One that impacted us all was, of course, the face mask and the respirators. But the other one that really impacted the medical community, the healthcare community, was the protective gowns. And the protective gowns are really engineered to keep fluids out. So, things like blood and bodily fluids, and they're supposed to also be comfortable and be protective, and so that was really a major challenge. And I remember there were companies here in North Carolina that were taking fabrics that are coated with silicone that are used for airbag filters, for airbags in the car, and using them as gowns. But even those fabrics, even though they're really heavily coated and they have all these coatings on them, would not make the highest level of protection. So that was a big, big challenge. And unfortunately, the type of machines that you need for those, it takes 6 months to install them, even if you had one ready, the installation. And so that was a major, major issue. I think the face mask, the issue was really not just the nonwoven, but the ability to convert. So we didn't have machines to convert them into face masks and respirators. And while a lot of these technologies were developed here, people were not doing that here. Because the U.S. under normal conditions is not a huge market for these, as opposed to the rest of the world.
So how did you counter the need? Because you did mention that the research that you do is basic, but from the way you're saying it, it's like your research came in extremely handy during that period. So how did you counter the need of the market during the COVID pandemic?
Well, I think I was getting about 200 calls a day, people who were asking for materials, and there were companies who wanted to buy my machines. And, so we very quickly recognized that there was a need. Actually, before the first case was announced, or right about the same time, we had a filtration show in Chicago. And so our community was there, and I was chairing a conference, but that's all we talked about. So we knew that the tsunami was coming, and our community was really talking about how do we handle the shortage. There was a lot of collaboration going on, a lot of dialogue going on, but they expected this to happen. But unfortunately, again, you can't just turn a button and create a new machine. And so we typically don't manufacture things because that's not what we do, but we know how to make a filter.
Okay.
And so we decided after discussions with the university that if we can use our assets and create some non-woven filters, then we would need to collaborate with some of our member companies and then who had converting capability. And so that's what we did.
Okay.
And then for the community, for us, not the medical community, there was a lot of interest in being able to cut and sew because we had capabilities for cutting and sewing, but the typical Maplone filter, you can't cut and sew. And so we actually, one of the very first fabrics that we created was a spun bond fabric that you could cut and sew. And so this was in the news because, one of our partners, Haynes, a large large company in North Carolina, they started essentially getting our fabric and cutting and sewing it into a duckbill mask, and they actually got FDA approval.
Wow.
And so they provided a lot of those to the North Carolina healthcare workers. And the ASTM came up with a new standard called a barrier mask, which was really for the community, not for the healthcare workers.
Okay.
And that single layer spun bond was the first one to actually get the accreditation, and it was on the website. So a lot of that was provided to the community at large, not just the healthcare providers.
Okay.
We had partners in North Carolina where we would provide the fabric and they would convert them into masks. And so a lot of collaboration.
That sounds amazing. So during this period, you have a lot of patents in your name. So during this period, did you get any patents?
During that time period, I think we applied for 2 or 3 patents on the work that we had done, but typically it takes at least a couple of years before you get those patents issued. But we had a couple during that time period.
Okay. And through your experience in patenting and in the field of nanotechnology, a majority of researchers in academia, they strive to get patented for something, a platform they designed. What can you talk about, like the trajectory of that journey when you realize that you have an innovation that could be helpful to the community and having to get a name for it and, acknowledging that it's yours?
Yeah, so I think in our discipline, we know the patent landscape. And so typically, if we identify a new solution to an old problem,
yes,
and the thing that we also look at is scalability. It's really critical because if it's not scalable, then it's probably too early for a patent. And nobody's going to sort of do that scale up. And so we look at the scalability, and then we do our due diligence, and we look at the current patent literature and make sure that what we are doing is not really just a minor incremental improvement. And the university has a really good technology transfer group that does their due diligence, and so there's a lot of dialogue before we invest in a patent.
Okay.
Because typically patents are pretty expensive, and if you don't really have a customer at the end, it just becomes an extra burden for the university.
Okay. And you have students who have worked on patents with you of their own, and they have, like, the patent is in their name?
Yeah, absolutely.
Okay. So who helps them with the financial implications?
Well, so I think, because they were graduate students at NC State, so they were still part of NC State.
Okay.
And so NC State took the responsibility for that.
All right. Yes, I invite my audience. They can also ask you questions.
Okay, so when I hear non-woven, I almost think about All right, so clearly there's a woven, and I don't know if it's antithetical to woven, but what was kind of like the final straw? Somebody looking at woven and like, okay, we need non-woven. Like, what was the final straw for people looking at woven materials to decide we need non-woven materials?
Yeah, so if you look at non-woven as a non-woven structure, it's existed for many, many, many years. If you look at wool fibers, people used to make felt by just taking wool fibers and creating a mat and then beating it and entangling it. And so that concept has been around for a long time. But I think the need that existed for really taking, say, textiles and shredding them and creating something new from them, that was sort of one of the very beginnings. So they created machines like a machine called garnet, where you take a garment and throw it in there and it would tear it up and fiberize it and give you fibers. But then those fibers were really a mix of different fibers and they had different fiber lengths. So you couldn't really just make them into another yarn structure or another textile structure. And so making it into a non-woven and making it into like a sound insulation or a thermal insulation was sort of one of the beginning ideas. But I think the medical community started looking at creating solutions for medical community in the 1950s. And they literally had to really reinvent how they would make a lightweight non-woven, because typically before then, most non-wovens were really heavy and thick and bulky. If you look at something like a medical gown, it's pretty thin and flexible and fabric-like. So they had to really think out of the box and figure out how to put all these processes together. To do that.
Interesting. And when you talk about, making the non-wovens for medical personnel, I think of current epidemics that we have, like antimicrobial resistance. Is there a way that the research that you do can help in making these PPEs that are resistant to bacteria, like, contaminants that would like to protect medical staff from?
Yeah, so I think the industry wasn't really looking at creating antimicrobial because then the question is, what's the end of life of that antimicrobial? And so the whole idea of a single-use garment was really that if it's contaminated, you treat it like a contaminated material, and so long as you can burn it cleanly and incinerate it without anything, the problem is solved. So even though that medical gown may not have been in contact with a infectious disease type person, but they still treat it as such. And so, in fact, the way they wear it, the way they take it off, they treat it as a contaminated material. And so they have really never had a need to put an antimicrobial on these because there's it's a single-use type of structure.
Okay, all right, okay.
So, yeah, that would mean that when you're considering non-wovens, based on what you said about a material that could be burned cleanly, they kind of take sustainability into account a lot when kind of looking at non-woven materials and methods, especially for like.
Yeah, so I think historically all medical waste is incinerated, and so that's been historically the process. So the question at hand is that if you create a gown with a new material, you want to make sure that when you incinerate it, you don't release toxic things into the environment, like fluorine gas or chlorine gas. And so if you look at polypropylene, it's basically carbon and hydrogen. So it's a perfect fuel. It burns cleanly, and leftover is just basically ash.
Yeah, you can go on and ask. So just the sustainability part of it, so it is a growing concern, I think, sustainability in the non-woven industry, or rather in the non-woven textile industry. How can it contribute to more sustainable practices, and what research is really going on around that area?
All right, so I think when we talk about sustainability, we have to frame it correctly.
Okay.
So are we talking about the carbon footprint? Or are we talking about unmanaged waste? Or are we talking about microparticles and nanoparticles. So people unfortunately mix all these things together. So if you look at nonwovens, historically and typically have very low carbon footprint compared to your traditional fabrics. If you look at the spun bond fabric, our power consumption, for example, is roughly about 1 kilowatt hour per kilogram of fabric, which is incredibly low. So I think when people talk about sustainability, they sort of forget about the carbon footprint, but they really look at material sustainability and end of life. And unfortunately, again, remember what I said earlier, that nonwovens are created to solve a problem. So they engineer, they put together. So sometimes we have different materials that come together to address a particular need. So now it may be difficult to take those materials and recycle them because those two materials may be completely incompatible. So one thing that's been happening in the industry is they're really trying to think from the very outset what the end of life is and design the product with the end of life in mind. For recycling, whether it's chemical recycling, advanced recycling, or mechanical recycling. And they're also looking at alternative materials. And so there's a lot of interest in bio-based materials and natural materials, which is really not related to the environmental sustainability, but people are also looking at those as well.
I have a comment and a question. So I did an internship in undergrad at DuPont working on Tyvek, which I think is considered a nonwoven, and they had a big push towards advertising their medical packaging as a way to combat like antimicrobial resistance. So I just thought of that when Faith asked the question. And then I have a question about a woven material. So I like to crochet, and I've always heard that there's like no way to make a crochet machine, and I was wondering if you know why.
Well, I think with nonwovens we can come pretty close to making something that would be similar. You know, with hydroentangling you can create amazing structures. So if you look at the name, hydroentangling, water jet entangling, spun lacing. So you could make a lace-like structure. And that's actually the very beginnings when J&J started working on hydroentangled fabrics for medical use. They looked like lace. They were putting patterns in there. They were creating textures that you couldn't do. And but unfortunately, these things are big assets. You know, they're not going to come with small machines, small footprints. Yeah, so the question of Tyvek has very, very high, so fibers have incredibly high surface area. It's got a really small pore. And bacteria cannot go through it. So when you have a medical packaging, it's breathable, so you can sterilize it using gas and what have you, but then bacteria can penetrate the package and go inside. So it's inherently antibacterial because the pore size won't permit anything in.
Interesting.
Thank you.
Thank you for that. I think you have addressed part of my question. It was about degradation in relation to the environment using the nonwovens. Number two, other potential applications beside the health section, something like thinking of the military or something like that. Are they applicable for such? And lastly, I was thinking about, are these nonwovens like kind of end product? Because if we are talking about PPEs, we are talking about respirators, you know, what if, are they applicable in the normal daily wear, you know? And would you, things like embroidery, or I don't know how to call it, paintings on the fibers of the fabrics, are they applicable, or the nonwoven are just end products in themselves? Thank you.
No. So the nonwoven really refers to a fabric. It's a class of a fabric. And then, you know, that fabric can be made by a variety of different techniques. And so they can go into a lot of applications. I mean, there's really no reason. So we can make actually a rug out of a nonwoven, and people are doing that. And these rugs have even patterns in them. If you look at your shoes that you're wearing, all the sports shoes, the synthetic leather that you have is actually a nonwoven that's been coated with a polyurethane. So so they're all nonwovens. If you look at a lot of the products that we use at home, like the Swiffer is a wipe. It's just a piece of a nonwoven. When you go grocery shopping to Harris Teeter or Kroger and you pull up a wipe, that's a spun-on wipe.
Okay.
For cosmetic removal, if you like coffee and the coffee capsules, your filter is a nonwoven in there for your Keurig coffee cup. Some of them use paper, and paper is not as good as the nonwoven.
Yeah, those are plenty that
Yeah.
wouldn't have thought it that far. Well, I think we have talked about the research aspects really, really deeply. Now, you are a professor and you have students under your mentorship, right? My question would be, I think from today's experience, you saw students ask questions. What advice would you give students who aspire to get into academia in textile research and students who are interested in industrial textile? Since you have had a balance of the two.
Yeah, so I think we did a gap analysis because our community typically hires from mechanical engineering, chemical engineering, chemistry, and so we wanted to find out what knowledge gap they have so they can start working on nonwovens. And so we actually we looked at that and we identified 5 areas. One is materials, because the materials that we use in nonwovens are very different because we use pulp, cellulose, we use superabsorbent powders, we use fibers, we use polymers, we use films. So we use a variety of different materials. And so the material component is really important to know. The second one is the products and the markets and the product segments. So, what is a wipe? What's an industrial wipe? What is it composed of? How is it made? How is it tested? So there's a big, really need for understanding those markets and product areas. Nonwoven processing, all the manufacturing, the toolbox that I showed from, the electrospinning to the melt blown to the spun bond, all of those processes, really understanding what they can do, what they cannot do, and how you can make a really good structure. The characterization that we do is very different because we characterize materials at the material level, at the fiber level, at the fabric level, at the product level. So when we talk about filtration, that's the product level. And then if you look at the wipe, you test the wipe completely differently from how you would test the filter. So there's a hierarchy of testing methods and characterization techniques. And then last but not least, how do you take all of these ideas and integrate them and be able to create a product? So really the product development piece or the product engineering piece. So we created a graduate certificate in nonwoven science and engineering, and it's going online this year, so you can take it online if you want to. And so all of our students actually have to complete one of these certificates. So this way, they not only get the benefit of their own degree, but they also learn about things that would enable them to go work and survive in this industry.
Okay, interesting. I think I like that. The one thing that I think I was hoping you could have mentioned in that knowledge gap was like, who dispenses this knowledge? The teacher or the professor who is dispensing. Is that also part of the knowledge gap, or we already have people?
It is.
Okay. Yeah. All right. Any other question? Okay.
I have a question. So during the pandemic, when you started making the face masks, Faith had asked about patents, and I was wondering if it's a situation like the pandemic where you want to get the technology out to as many people as possible. Is it better to patent the work or not to patent it?
So I think this is my personal view, that I think we all have a responsibility that if we have a technology that can help people and we just sit on it because of a patent, I think that would be a shame. But fortunately, you can file a patent and yet you can start commercializing things and you can say patent pending. And I think that's what most people did during the pandemic.
Great, thanks.
I have 2 more last questions, if you don't mind. So what does the future look like? What do you envision as the most promising advancement in technology in the textile industry?
So I think, so I'm going to focus on the nonwoven industry because I think nonwovens and textiles are somewhat different in terms of their focus. For nonwovens, I think the carbon footprint is a really big deal. And as I mentioned, our carbon footprint is really low, but we're still trying to go much, much lower. So that means creating more efficient machinery, less waste. Many of our companies have gone to zero waste. So essentially all of the edge trims and whatever they have is put back into the process. Using less. So if I'm making a fabric today that's 50 grams and I could make it 25 grams, that would be a huge undertaking, but easily said, not easily done. Because that would require for you to really reinvent a lot of these technologies to meet the same requirements at half the weight. But if you did, that would be a massive breakthrough. Yeah. And so if you look at all of our leading companies, they all have a sustainability goal on their website. And some of them are really addressing these issues in terms of where can we make the biggest impact today and where can we make the biggest impact over the next 10 years. So if you look at a lot of the waste that ends up in the pictures on the front of the National Geographic and everything else is the packaging. Except during the pandemic, you could also see face masks and people were just putting those on every page. So one area that you could make a huge impact is packaging. So if you look at all of our leading companies are now going to more bio-based packaging or going to more natural-based packaging materials. Yeah. And then they all have goals of reducing weight, reducing carbon footprint, and really then redesigning the components in the meantime so that they're, again, designed for end of life in mind and using more sustainable materials. But it's all going to take time.
It's a work in progress.
Yeah.
It's a work in progress. So lastly, what message or what words of wisdom would you like to share with current students, future mentees who may want to embark in an academic or professional journey in the field of nanowoven?
Yeah, so I think for every student that we train, and by the way, 99% of our students end up working in the industry, and for every student that we train, there's probably 10 openings. And these are really interesting jobs. They pay well, the job is interesting, the challenges are real, the companies are really good to work with. And so, take a look at, focus areas in nonwovens because I think the industry needs it, our future industry needs it, and I think it's going to be a really rewarding type of a career.
Have you enjoyed your experience so far in research?
Yeah, I'm going to do this for another 60 years, yes.
Congratulations. Thank you so much, Dr. Behnam. It's been exciting. I haven't talked about textile like this today, but I've really enjoyed the conversation.
Thank you.
It's been such an honor to have you here.
Thank you so much.
Thank you very much.